want to know the equations of a line from some of the given informations. So let's look at the first question and see how to tackle the informations on equations of a line. From the question, we are given this guy here that will be minus 1,5 and the gradient to be 1/2, and they say you should find the equations of the line. The first question you should ask yourself is exactly, do you know who or what we call the equations of a line? That is one thing. You must know the person before you can easily find it. Just like when I say give me a marker, a board marker. Of course, this is what a red board marker. You know exactly what a marker is. That is why you can go for it. But here, do you know the equations of a line? That is the first question you should ask yourself before you move on. So what exactly, or what do you call the equations of a line? When you say equations of a line, this is how exactly the equations of a line looks like, something like this or something of this nature. Don't worry if you are seeing a variables or a numbers here, and I'll explain that in just a few minutes. So this is how the equations of a line looks like. It looks like this guy or that guy. But what exactly takes us to this place is this driver here, right? Call it a driver because it's the guy that is going to take us to this point. So this is one thing you must know before you can find any equations of a line. So when you say equations of a line, this is exactly what you have to use to find the equations of a line. If you don't know this guy, then forget, right? Just like in the first scenario, you know the marker, that is why you go for it. But here you must know exactly what or who you call the equations of a line to use it perfectly. So this guy is the equations of a line that will lead us to this point. So let's look at how to use this guy to solve the problem being given. As I said earlier on, we are giving this guy and the gradient, and they say you should find the equations of a line. So now that we know what we call the equations of a line, this is what we call the equations of a line, right? So you need to write it down. So this is exactly what we call the equations of a line. That is y minus y1 is equal to mx minus s1. Look at something. The only thing that you need here is this guy here, the y1, the m, and the x1. Right? You need these three guys out of the equations of a line for everything to be in perfect condition over here. Now the y1 here is from this guy we are giving minus 1,5. So the first one here is the x1, and this is the y1, right? The x1 is the minus 1 here, and the y1 is the 5 here, and we are giving the gradient. The m here is what we call the gradient. Right, now that you know this y1, you know m, and then you know your x1, you are free to go. Then you can easily find your equations of the line. Okay, so the equations of the line here, now that you know that y1 is equal to 5, your m here is the gradient, m here is the gradient, that is 1/2, and the x1 here is the minus 1 here. You just need to plug them, right? You just need to replace them from the name of the equations of the line. Therefore we have y to be y minus 1, yeah, right here is y1. That's so the y1 is 5, so y minus 5 here is equal to 1/2. We are just replacing, right? We are just replacing from these equations of the line. So 1/2 into bracket x minus 1. Look at something, the x1 here is minus 1, so don't let this minus 1 here confuse you, right? So you are having x minus 1. So we know the plus, multiplication, or the subtraction already. So here all I have to do here is that this is a fraction, so you have to multiply everything through by 2. So after multiplying here by 2, I'm having 2y minus here everything. So I'm having one guy here, one guy here, one guy here, as well as one guy here. So we are multiplying everything, all the 4 times by 2, right? So here should be 2y minus 10. That is equal to, if you multiply here by 2, I will say that this 2 will cancel the 2 here, right? So that is how I got my x plus, you see there's a minus here, so this guys will tend to be a positive. So plus 1. So when you do everything correctly, you should arrive at 2y minus x minus 11 to be equal to 0 is the equation of the line. That is exactly what I explained earlier on. So this guy looks like the equations of a line. So remember that this is what brings us to the equations of a. You must not forget this boy, right? You must not forget this boy in terms of the equations of a line. So look at the second question here. Second question here. From the second question, you are giving two different people here. What I mean by the people, you have P and what? The Q. So P looks like what? -4, what? 3, and then Q looks like 2, what? -6 here. They say you should find the equations of the line. Now that we know that this is what we call the equations of the line, right? We know that this is what we call the equations of the line. And out of this, we need what? 3 people. We need the y1, we need the m, as well as the x1. So these two guys are just something that we assuming we don't know, right? They are random numbers. So only thing that we need out of the equations of line are these 3 guys: the y1, m, as well as the x1. Now we know that the y1 and the x1 are what? Look at something here. We are giving two different points here. Now we know that the m here is the gradient. We are not giving the gradient. We are just giving only these two guys. But out of these two boys here, we can find the gradient, right? Out of the P and the Q, we can easily find the gradient by using this guy, right? This is what we call the gradient. So if you want to know the gradient, this is what we call the image of the gradient. Looks like this. So the m here is the gradient here, and this is how it looks like. That is the y2 minus y1 divided by x2 minus s1. Right now, it's your duty to know exactly where the y2 is coming from, where the s2 is coming from, where the y1 is coming from, where the x1 is coming from. So from this point be given, the -4 here will be your x1, and this one will be your y1, and then the second guy will be what? Your s2, and then the y2. They work in pairs, right? S, y, S, y, just like you walk by two of your legs. So this is the first guy here, the x1, the y1, and then x2 and what? The y2. Remember, it's not xs, it is not yy, it's x, what? Y. So the first guy is the x1, y1, and then the second guy is what? The x2, what? Y2. Now that we know that, we are free to go. We just need to replace that in the what? The gradient image here. So the image of the gradient, that is what? Y2 minus y1 all over what? X2 minus s1. So what is the y2 here? So y2 here is what? -6, right? -6, and then the y1 is what? Positive what? 3 here. So we have what? Y2, which is the -6 over what? Minus what? 3 here, and then all over the x2, which is 2, minus what? -4. Remember that it's -4 here because the x1 is what? It's exactly -4. That is what we are having here. Okay, so when you do this calculation, you should arrive at -3 over 2. So this guy here is the gradient now. Now that we know the gradient, we are looking for the gradient for us to find the equations of the line, as well as the x1 and the y1. So this x1 and the y1 can be any of these two guys, right? Can be any of the, so maybe to avoid any confusion here, you should go for this guy, right? So that is exactly what we have here. That's the x1 and y1. So now we know the x1 and y1 as well as the gradient, right? So that is how I got to this point by saying that using the point of -4, 3, we are using this guy as what? The x1 and the y1, right? The x1 and the y1. Now that we find all the 3 things that we need to find our equations of the line, we are free to go. We have the gradient as well as the x1 and the y1. We just need to plug them into this guy, right? Because this is what we call the equations of the line. So we plug them in. We are having y minus the y1, which is 3 here, -3 is equal to 1 over, sorry, that is a -2 over 2, which is the gradient, right? The m here. Okay, then into bracket x minus -4. So here we are seeing the -4 here. Don't be confused with the negative here, right? So whatever the x1 is, just replace it. We are just replacing it in the equations of the line. So do the calculation as we saw in the first example. Here you just perform here there's a fraction here, so you have to multiply everything by 2. So 2 multiplied by this y will give him 2y. 2 multiplied by this guy will give him -6 here, and then the 2 goes away. Here we are having -3 into bracket x plus 4, right? So expand the bracket here will give me 2y -6 is equal to -3s or -2. So send everything to the right hand side. You should arrive at something like 2y -3s plus 6 is equal to 0. So this is what the equations of line. This is how this type of the equations of the line looks like. If you enjoyed the video so far, you may consider subscribing to the YouTube channel for more content like this. Share and like or comment down below if you have any issue. Now here's another type of equation that says that you should find the equations of the line being given from this information. from this question we are giving, now here we are giving the equations of the line to be equal to y equal to 3 over 2x plus 5, and then we are giving another point to go 2, 3, and then they are asking you to find the equations of a line that is parallel to what, to this guy, right? So what it means here is that you and I know perfectly that for us to find the equations of a line, this is what you have to use, right? This is exactly what you have to use, and out of this we need a y1 m, which is the gradient, and what, the x1 as well, for it to get the equations of a line. Now here we are giving one equations of a line, right? That looks like this. Is that okay? And then you are giving another point to go 2, 3, and they say you should find the second equations of a line that is parallel to what, to this guy. Don't let these guys scare you here. The word parallel here, it means that maybe they cannot meet. Maybe two of you, maybe you and your sibling, so you are walking this way, your sibling is also going this way. Have you see? The two of you can never intersect. What I mean by they can never, you guys can never meet. That is why we are saying it is what, parallel. So if it is a parallel here, then you look at this definition here. If this equation here is parallel to what we are going to look for, what it means is that this guy, a friend of x, so the guy attached to the x, that is what I'm calling the friend of x here. So the guy attached to the x here is the gradient, and then the gradient of this guy is the same as what, the gradient of what, the parallel line. So what we are going to look for, right? So that's what I have here. The gradient of the line parallel to what, the given line is also what, 3 over 2 here. So the guy attached to the x here is what we call the gradient. And then remember that we need the gradient as well as what, the x1 and the y1 to find the equations of the line, right? Okay, so the guy close to the x here is the gradient. Now if they say a line is parallel to whatever you want to look for, then it means that they all have the same gradient. That is one key there, right? If you ask you, maybe you and your sibling, the two of you are having the same surname, then what does it mean? It means that maybe your father or your great-grandfather is also bear the same name. That is just a definition, right? So when you say that this equation here is parallel to what we are looking for, then it means that those two equations have the same gradient. And we know that the gradient here is the guy that is attached to the x. Okay, so the guy attached to the x here is, that is what, 3 over 2. Now that we know the gradient, we can just use the point. Then we are giving this point to be what, 2, 3. Now we know the gradient as well as what, we know the point here, that's the x1, y1. Then we are free to use what, these definitions of what, the equations of your line, right? So that is one key word here. Now that you find your gradient and the point, just plug in, right? You have plugins. That is all you got to y minus 3 is equal to what, 3 over 2 here, x minus 2. So do your thing, right? Just do the thing. Use these two to multiply us, and then you arrange everything perfectly to arrive at what, that is what, 2y minus x to be equal to 0, right? So the key here is that when they say equation is parallel to something that you are looking for, what it means that the gradient, and the gradient is the guy that is attached to the x here, right, are the same, right? So the parallel lines have what, the same what, gradient here. Okay, now look at this next question here. That says that from the question you are given the equation, but they say you should find another equation that is perpendicular, right? Perpendicular here, right? This is a perpendicular. This word here, you should know exactly what it means, just like in the case of the parallel line. So the gradient of the equation given to us in the question is 2. Remember that I said the gradient is the guy that is attached to the x from the question. So the guy attached to the x there is 2. That is what we are given. And then you say you should find another equation that is perpendicular, right? The two of them are perpendicular. So meaning that if they are perpendicular, the gradient of one is what? The negative reciprocal. So don't worry about that word. What it means is that if something is a negative reciprocal of something, you just need to swap the thing upside down. So if you say that my age is 2 here, and I say your age is the negative reciprocal 1, if you say it is the reciprocal, it means also yours is 1 over 2. Reciprocal, we are reciprocating it, right? We are turning it upside down. So something like that, just for understanding people. So if 1 is this, and then the reciprocal of that is that is always 1 over whatever you are having. So you are here, your friend is negative or is reciprocal to what you are having. It means that your friend looks like this. So now they say it is negative, so you need to bring the negative here in front of that, right? If it looks like this and your friend is a reciprocal of what we are having, that should be what? 1/2, right? 1/2, 1 over whatever you are having. Now we said it is negative reciprocal, so here should be what? A negative. This is just the meaning of the perpendicular, right? The gradient of what? A perpendicular line is the gradient of one perpendicular line is equal to the negative reciprocal of the other. So what that in English means is that we are having the gradient of one line to be 2, and then what we are looking for, the equation of the line that we are looking for, they say that line is perpendicular to whatever it has been given to us, right? So that perpendicular line here, we need a gradient. Remember, we need a gradient and a point. Of course, we are given the point to be 2,5 here. So the only thing that we need here is what? Is those gradients, right? We are given the point, so we need the gradient. And how do you get a gradient here? That's why I said it's a negative reciprocal. So you have the gradient of 1 to be what? 2, and then the next one, that which is perpendicular to what we are giving, should be what? 1/2. That is negative. That, remember, I said the meaning of this guy, the perpendicular to another equation, is negative reciprocal, right? Negative. This is what we have. So negative 1/2 will be what? Our new gradient. So once we get a gradient of the perpendicular line and the point to be what? 2,5. You are free to find the equations of a line using the definition of the equations of line. That says that y minus or y1. So the y1 here will be what? 5 here. That is equal to what? The gradient, which is what? Minus 1/2 x minus 2. So multiply through by 2, you should arrive at what? 2y plus x minus 12 is equal to. So this is the new equations of a line that they're asking us to find. But this is how simple and easy you use the equations of a line. You find almost all the equations of a line in mathematics. If you've enjoyed it, don't forget to give us a thumbs up and subscribe to our YouTube channel for more content like this. Thank you for watching.